Welcome everyone. I am Dr. Ahmed Shafai and I will be your instructor for CSCI 4330 Software Development. Many of you may remember me from our Data Structures and Algorithms class, as it is a prerequisite for this course. Compared to the Algorithms course, this one will be much easier, and I believe it will be a really interesting and engaging experience for all of us. For this course, we will be using the textbook Software Engineering, 10th edition by Jan Somerville, which will serve as our primary resource. In today's lecture, I will start with an introduction to the software development process and why it is important. Then we will go over the different software product categories and the characteristics of high quality software. I will also introduce the software engineering process, discuss issues that may affect software, and touch on software engineering ethics. Finally, I will introduce the four case studies that we will refer to through the course as an examples. Software engineering is the foundation of modern life, supporting the technologies that we rely on every day. Almost every aspect of our life relies on software, such as security, healthcare, utilities, manufacturing, finance, entertainment. And when I say entertainment, I think about something like the streaming service platform or game development. And finally, the personal mobile devices, which is owned by over 80% of the global population. The question now is, why do we need a software development course when we already have strong skills in programming, data structures, algorithms, and more? The answer is straightforward. Even the most talented programmers can see their project fails without software engineering process. So, what are the reasons behind project failure? The first reason is the increase in systems complexity. Systems today need to be built and delivered more quickly. However, they are becoming larger and even more complex. This graph showcases the exponential growth of software size each year, specifically in military aircraft. The y-axis here represents the KSLOC, which stands for thousands of source line of codes. Moreover, consider the game software. I used to play this game called River Raid when I was kid, and I only need these four or five buttons: the arrows to control the aircraft, and the space to fire or to shoot. However, games today are incredibly complex. You might find yourself using almost every key on the keyboard, and sometimes combination. You have to press Alt, Control, and C to hide or to do whatever. So it is becoming really complex. Even some games include using new devices like Oculus for virtual reality game. So employing software engineering techniques will aid us in developing this larger and more complex system in more systematic way, and we can guarantee that this system is reliable and acceptable. The second reason behind system failure is related to project cost and reliability. Writing computer programs without applying software engineering methods and techniques might seem straightforward. Many companies have ventured into software development without implementing this software engineering practice, and the consequences were devastating. Their software turns out to be costly and it makes sense because in software development or in software engineering, there is a process related to estimating the cost of your project. So if you didn't use this systematic way, your cost either will be very cheap and this will lead to you will not gain any profit from this software, or it will be you will estimate the cost as a very high cost, and that way no user will be interested on buying this. Another problem is reliability. Without using the software, without the software engineering process, your software will tend to be less reliable. Why? Because in software development process, we have an activity related to the validation, and you will learn a lot of methods to do this testing. Without this, your testing process will be conducted in a haphazard way. So in this course, we will learn various testing techniques to ensure that our software is reliable. Software engineering are responsible for developing software products that can be sold to customers. These products fall into two main categories. The first one is generic products, and the second one is a customized product. The generic product, these are a standalone system created by a development organization and sold on the open market. Example for this include Microsoft Office, Acrobat Reader, VLC, Photoshop, various browsers, and of course games like Call of Duty. For the customized product, these are systems commissioned and developed specifically for a single customer. For instance, shopping application for Kruger or Walmart, banking applications, um, software for hospital or for schools. The primary difference between this kind of product or these two categories of product is that the software specification for generic product is controlled by the developing organization. In contrast, the specification for customized product is controlled by the customer, meaning that software developer must adhere to this specific requirement. Maybe you think like that way the generic product will be much easier to be implemented. And I want to say that while the developing organization is the controller of the software specification for the generic product, it is tough to decide this specification without doing an extensive research about what is the market is in need to, and what is the specifications that have to be in this product. In contracts, the customized product will give you a clear specification from the user that you need to adhere to it. So this is easy. I mean, I need this specific and this characteristic, or I need this functionality in my product. As far as I deliver this functionality, I'm in good shape. But for generic product, I have multiple customers with different ideas, and I have to do this research on the market to understand what is the needed functionality to be in my product. And to be honest, the distinguishing between the generic and customized product is not that clear. Some products start as generic product and then customized based on specific user need, such as something like Workday. Workday is a generic product but is customized for every company. And Workday is example for an HRM system, which are human resource management system. You can think about CRM system, customer relationship management system. There is a lot of products start as a generic product, then we need to customize it for certain users like Salesforce or Siebel. Now let's jump to the software quality. When assessing the quality of professional software, it is essential to consider that software is used and changed by people other than its developers. And when we say quality, we don't mean only the quality of the software function, like it doing the function very fast, but also we care about the structure and the organization of your code. And sometimes we even care about the software documentation. If you will create a user guide on a website or a document to help the user know how to use this software, this is part of the quality assessing for that software. The expected attributes from software system depend on its application for sure. For instances, an aircraft control system, we should prioritize the safety in application like this. While for an interactive game, I believe we will prioritize the response. I need my game to be responsive. I don't think about having a game and when I fire or hit the key to shoot the enemy and then the program is not that responsive, so I take time. This way, the game will be very boring and no one will actually will use it. And for application like telephone switching, I need this application to be reliable. Whenever I want to contact to someone, I want to have the ability to contact him and I want to contact the right person. Don't contact me to another one. However, while this is when we are caring about the attributes, it depends on the application, but there is a general attribute that we need to care about for all application, regardless its use. The common attribute represents the essential characteristics of almost every professional software systems are acceptability. And acceptability is very important for software to work well. It needs to be made for its users. This means it should be easy to understand, easy to use, and easy to work with other systems. Think about it if you have a great software but people cannot use it or get it. Then it is not doing its job. Next, dependability and security. Dependable software lasts a long time and handles problem well. It doesn't break easily and make sure no one get hurt or lose money if something goes wrong. Think about it for people who took the database class. When we think about the transaction, think about it like this. You are at front of an ATM machine, you insert your ATM card and you ask to withdraw a certain amount of money and then a system failure happen. How the system will handle this problem? Will it give you the money and will not take it out from your account, or it will take it from your account but will not give you the money? If this happen, we have a problem with this software. At the same time, um, uh, many online danger can happen, so we need to keep our software safe. And safe is not just a nice thing to have, it is a must. You have to have your system secured, especially when we are using this system in almost all our aspects in daily lives. The third one is the efficiency. Efficiency is when things really work well. Uh, Good software does its job without taking up too much power or space. So we need our system to be. Do you remember when we talk about the space complexity and time complexity in algorithms? So we need our system to work well, work fast, and don't use a lot of space. And for finally, maintainability. In our fast evolving world, the software needs to adapt and evolve very fast. It should be constructed in a way that welcome changes, tweaks, and enhancements. This adaptability ensure longevity and relevance in a dynamic business environment. What is software engineering? Software engineering is an engineering discipline that encompasses all elements of software production, from the initial stage of system specification to maintaining the system post deployment. And why software engineering? Software engineering is vital for two reasons. The first one is reliance on advanced software systems. As individual and society increasingly depend on sophisticated software system, it becomes crucial to economically and quickly produce a reliable and trustworthy system. And of course, for cost effectiveness. In the long term, using software engineering method and techniques for professional software systems is often cheaper than treating them as a personal programming project. Failure to apply software engineering methods can lead to an increased cost in testing and even quality assurance, and also for the long-term maintenance. The systematic approach used in software engineering is often referred to as a software process, which is a series of activities leading to the production of a software product. There are four fundamental activities common to all software processes, which are software specification. This step involve customers and engineers defining the software to be produced and its operational constraints. Software development. This phase focus on designing and programming the software. Software validation. This step ensures the system meets the customer's requirement, working correctly, and usually we are doing the testing phase during this activity. And finally, software evolution. This stage involves modifying the software to meet changing customers and market demand. There are a lot of challenges that can face or affect software. And the key challenges affecting different type of software are first heterogeneity. Uh, Increasingly, systems are required to operate as distributed systems across networks that include different types of computer, mobile devices, and even different systems. And of course, business and social change. Business and society are changing incredibly quickly as emerging economics develop and new techniques become available. They need to be able to change their existing software and rapidly develop new software. Think about something like the virtual reality that start to trend at certain time. Before we don't have this kind of games, but we need to change. I mean, the environment is changing so fast, and your system have to cope with this change. Security and trust. As software is interleaved with all aspects of our life, it is essential that we can trust that software. Trust software that will work well and is secure, so it will not cause any harm or any breach to my information. And the scale. Software has to be developed across a very wide range of scales for very small embedded systems like your smartwatches or any portable device to an internet scale cloud-based system that serve a global community. And to tackle these challenges, innovation ways of using existing software engineering methods and new tools and techniques will be necessary. There are many different types of software system, and there is no universal or general set of software techniques that is applicable to all of these. So the software engineering methods and tool used will depend on the type of application being developed. So what is the different types of application? I encourage you to pause the video at this point and think about the application software types that you are familiar with. You can think about something like standalone application. It is the applications that function independently on a PC or a mobile device without a need for network connection. Example for this, the Office application, Microsoft Office, CAD program, photo manipulation software like Photoshop, Photo Impact, and various applications that is not in need for a network. Interactive transaction-based application. It is the application that operates on remote server and users access via their personal devices, such as web application, cloud-based services like email or photo sharing. Another type, which is embedded control systems. This system control hardware devices such as mobile phones, autonomous vehicle, anti-lock braking systems in car, even microwave oven controllers, and batch processing system. These batch processing systems have an extensive or huge amount of input data and a huge amount of output data. Business system designs to process large batches of data such as periodic billing system, payroll system, or are some instances. Entertainment system primarily designed for entertainment purpose like games. Systems for modeling and simulation. These software systems help scientists and engineers to simulate a physical process or simulation involving multiple interacting objects. Data collection and analysis systems, such that collect data from their environment for further processing. They might interact with sensors like weather stations. Systems of systems. These systems used in large organizations and or consist of multiple software systems, which can include generic and custom built systems. They are connected together. Think about the system for the whole university. We have system like Workday that controls the payroll, contact with the whole system of the university that have a system related to the student, the enrollment of classes, tuition handling, and all other stuff. There are some fundamental principles that apply to all types of application software system, irrespective of the development technique used. Uh, For example, development should follow a well-planned and comprehensible process with a clear vision of the output and the completion timeline. The exact process used depends on the software type being developed. For all system types, dependability and performance matter. Software should operate as anticipated, be available when needed, and ensure safe operation and security against potential external threat. Efficient performance and resources conversion are also important. Understanding and managing software specifications and requirement is vital. It is essential to comprehend the expectations of various system users and manage these expectations for timely and budget compliant system delivery. Existing resource should be effectively used. Prioritizing software reuse over new development is advised when it is visible. Let's now jump to internet software engineering. The web is now a platform for running different applications, and this help in reducing the cost for both users and software company. But the question how this happened. First, it leads to have application funded by ads, so you don't have to pay for the application. You will watch the ad, and this is how you pay for it. And moving the deployment from the individual PCs to web servers reduce the cost on users. You don't have to have a powerful machine. All what you need is just a web browser. This change in software organization has had a major effect on software engineering for web-based systems. For example, software reuse. This involves considering how to assemble system using pre-existing software components and framework. When I'm thinking about example for that, I think about something like Shopify is reuse payment gateway like Stripe or PayPal APIs. And for security, they are using components like Authenticate. It is also widely accepted that dealing with all the requirements in advance is now unfeasible. Instead, we will use an incremental and agile development style. For example, in Instagram start without stories features and then they add it. So we can keep doing that. For Facebook, we start without reacts. It was only the like button, and then they add multiple react like care, angry, sad, or whatever. Implementation of software can be achieved through service-oriented software engineering, where software components exist as independent web services. Think about Uber application. Uber use payment services like Stripe, using geolocation services like Google Maps, and the main system communicate between these services. And finally, the rise of interface development technology like Ajax HTML5 has facilitated the creation of features rich interfaces within web browsers. So, for example, in Google Maps, which is using Ajax, by the way, stands for asynchronous JavaScript and XML to create rich interfaces. When you zoom or drag on map, instead of reloading the whole map, Ajax load only the new map data. And for YouTube, when use HTML5 to allow embedding videos and having a very good interface. Software engineering involves wider responsibilities than simply the application of technical skills. Software engineers must behave in an honest and ethically responsible way if they are to be respected as professional, and it is just related to the agreement that you are signing. I mean, it goes over that. So let's discuss some of these principles. Firstly, confidentiality. Imagine sharing personal secrets with a close friend, trusting they will never disclose them. This trust is crucial. Similarly, engineers have an inherent duty to respect and protect confidential information, irrespective of any written agreements. This is not just about adhering to agreement, but about honoring the trust that client and employers place in us. Moving on to competence. In an era of constant technological evolution, it is tempting to oversell one's skills. However, engineers should never misrepresent their capabilities. Accepting tasks beyond one's competence doesn't just endanger projects, but also the reputation and safety of individuals and organizations involved. Thirdly, intellectual property. Intellectual property is the lifeblood of innovation. Engineers must familiarize themselves with local laws regarding intellectual property rights, whether it is patent, copyrights, or trademarks. It is our responsibility to ensure that the ideas, code, or designs are protected and created to the rightful owner. Lastly, computer misuse. Uh, with great power comes great responsibility. Software engineers equipped with specialized skills must never misuse them. While playing a game on an employer's machine might seem harmless, activities like spreading viruses can have devastating consequences. It is our moral duty to use our skills for betterment of society, not to its detriment. In conclusion, as engineers, we are not just bound by codes and algorithms, but also by the code of ethics. I shared with you the ACM Software Engineering Code of Ethics links in the resource book, and this module assignment will be about providing explanations and example for these ethical principles. So I hope you enjoy this assignment. To demonstrate software engineering principles throughout the course, we will utilize examples from four different types of systems used by our textbook. The first case study is a personal insulin pump, which is an embedded system in an insulin pump used by diabetics to maintain blood glucose control. The second one is a mental health care patient management system named Menticare, which is a system used to maintain records of people receiving care for mental health care problems. The third case study is a wilderness weather station, which is a data collection system that collects data about weather condition in remote areas. And finally, iLearn, which is a digital learning environment, which is a system to support learning in schools. That's all I have for you today. Thank you so much for watching this video and see you in the next module. Bye.